Hello guys, so we are back again, and in this session we are going to solve some more questions on chain rule, and this lecture is going to be probably the last lecture of chain rule. But before starting with the questions, I want to say that please subscribe the channel so that we can bring more content to you guys, engineering related, and don't forget to share it with your friends and others who are in engineering currently, so that they can get the benefit of these lectures. So let's begin with the lectures, with the questions. The question which we are going to take is this: if z equal to f of x comma y, where x equals to u cos hv, y equals to u sin hv, then prove that dou z by dou u the whole square minus 1 by u square dou z by dou v the whole square equals to dou z by dou x the whole square minus dou z by dou y the whole square. What we are going to do, first you have to write this first same thing. If you are able to draw the chart which I told you, then you will probably going to get the right answer. But if you are not able to draw the chart, then there may be chances that you make mistake, right? First z is there, then it is a combination of x and y, which are further combinations of, what are the rest of the combinations, are u and v, u and v, u and v. Now one thing you should be careful here is that they are not circular functions, they are hyperbolic functions, hyperbolic sines and hyperbolic cosines, cos hv, sin hv. Now since we have drawn the chart, what we can do is represent this x comma y, u comma v by chain rule. What we can see, dou z by dou u is the only thing which we find, dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u, right? So dou x by dou u is nothing but dou by dou u into, if you differentiate this, u cos hv, it will be nothing but cos hv, cos hv. Now dy by du is equals to d by du, u sin hv. This will be nothing but sin hv. Okay, now what we are going to do is that substitute these values here, so which will give me dou z by dou u equals to, what we are going to get from this is as follow. Let me put the values. So dou z by dou x into, if I substitute this value, I am going cos hv plus dou z by dou y. If I substitute this value, I have sin hv, right? Now what we need to do, we need to square this. The moment I square this, dou z by dou u the whole square is equals to dou z by dou x the whole square cos h square v plus dou z by dou y. Just keep in mind that these are hyperbolic functions, okay? Don't get into hasty and apply cos square theta plus sin square theta equals to 1. I am warning you because these are hyperbolic functions, so be damn careful before doing anything, right? What we are going to see is that we got this thing, we will call it as 1a, let's call it as a. Now what is our next target? It's d dou z by dou v. So by chain rule, similarly we can say, similarly dou z by dou v is nothing but dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. Just do one thing, dou x by dou v you can get this time by observing this. We are not going to do that, okay? We have said similarly. So if you don't show this step, it is fine. So cos hv is nothing but, okay, u cos hv, u will be as it is. Cos hv in hyperbolic, when we differentiate cos hv, it is sin hv. There is no negative sin hv. So don't do that mistake. Many children do that mistake. Dou z by dou y by dou v is u sin hv will be u cos hv, and here dou z by dou v. Here I forgot to mention to this reason squaring both the side. Please you keep in mind this, writing these reasons. Now here squaring both the side and dividing throughout by u square. What we are going to get? Dou z by dou v, the whole square, 1 by u square, which will be nothing but dou z by dou x, the whole square, u square sin h square v, dou z by dou y, the whole square, u square cos h square v, and here we are going to be left with 2 into dou z by dou x into dou z by dou y. It will be u square sin hv into cos hv. If I divide it, this will be 1 by u square, here also it will be 1 by u square, here also it will be 1 by u square. So finally you are going to get dou z by dou x, the whole square, into sin h square v plus dou z by dou y, the whole square, into cos h square v plus dou z by dou x into dou z by dou y. Here 2 will be there, and sin hv into cos hv. Now you can see one thing, that they have given dou square, dou z by dou u the whole square minus dou 1 by u square, dou z by dou v the whole square, subtract. And if you should know this property, that cos h square v minus sin h square v is nothing but 1. You should know this property. It's very important property. You should keep in mind. Okay. So if you know this property, what is the benefit of this property? That it becomes 1. So if you observe dou z by dou u the whole square minus 1 by u square, dou z by dou v the whole square, it is nothing but, this thing will come here, and here you can see cos h square v minus sin h square v. So I am left with dou z by dou x the whole square. I am not writing all the values again and arranging the terms. You can understand this much. Now since it is subtracted, these two terms, this and this, will nullify, and here again sin h square v and cos h square v, I am going to left with dou z by dou y the whole square with a minus sign. Now how minus sign appear? Because here cos h square v minus sin h square v is there, right? And here it was minus sin cos square v minus sin square v. When I subtract here, minus cos h square v will be there, sin h square v minus cos h square v will be there. But we know the formula is cos h square v minus sin h square v, so I have to take minus outside, then I am going to get this value, hence proved. Now we are done with this problem. Hope you have understand each and every step of this problem. Now let's move on to the next problem. So the next problem which we are going to take is the last problem, is as follow. If x equals to p cos theta minus q sin theta, y equals to p sin theta plus q cos theta, and u equals to f of x comma y, prove that dou square u by dou x square plus dou square u by dou y square equals to dou square u by dou p square plus dou square u by dou q square. Now you should know this, because first you should write this all the things. Here they have given second order derivatives. So how you will be able to click that we have to use chain rule in second order? Okay, it depends on your practice. Okay, there is no other alternative. So how we can proceed? First you should know that your main function is what? Central function is u. It is broken up into x and y, which is further broken up into p and q. How I make out that it is broken up into p and q? Because here p and q are there. So what we are going to do, we are going to mention this thing, x comma y, that this is a function of p comma q. If you have mentioned this thing, we will get dou u by writing by chain rule. This is one by chain rule. Dou u by dou p is nothing but dou u by dou x into dou x by dou p plus dou u by dou y into dou y by dou p. So if you observe, dou x by dou p is nothing but dou by dou p. Here if you differentiate, p cos theta minus q sin theta, which will be nothing but cos theta, right? Because I am not partially differentiating with respect to q or theta, so my target will be only p term, and dou y by dou p will be dou by dou p, p sin theta plus q cos theta, which will be nothing but sin theta. If I substitute here, I am going to get dou u by dou x cos theta plus dou u by dou y sin theta. I'm getting dou u by dou p. Now I need to get the second derivative. I will call it as a. Now the second derivative, which will be, I will differentiate this with respect to p again. So what I'm going to get, this derivative will again this partial. Okay, I will mention x comma y. How I am able to get the chain again? The chain is because the partial derivative will follow the same chain. So if you know this, what you are going to do is partially differentiate this, which is dou a by dou p. But I know my dou a is what? Dou u by dou p. But for the timing, I'm going to apply the chain rule, which will be dou a by. Now the graph will change. A to what? Here x, y, and from here p, q, and from here p, q. Again, dou a by dou x by dou p, dou a by dou y by dou p. Right? Now what we are going to do? What we are going to do actually is get this value, which will be again same, because we have already got those values. So we'll substitute that dou a by dou x cos theta plus dou a by dou y by dou p sin theta. If I substitute that, I'm going to get a value. Okay, now I'm left with this thing. Now I don't have anything left. So what my task should be? Put. Okay, I'm going to write here, put the value of a. So here it will be dou a by dou p, so it will be dou a by dou p into dou u by dou p. As you can see, this cos theta will be as it is. It will be dou by dou x into what was it was dou u by dou x into cos theta plus dou u by dou y into sin theta. plus what extra is there? Again here sin theta will be outside, here dou by dou y into what? Dou u by dou x, dou u by dou x cos theta plus dou u by dou y sin theta. Now if I simplify, I'm going to cos square theta dou square u by dou x square plus sin theta cos theta dou square u by dou y square. Similarly again dou square u by dou y dou x cos theta plus dou square u by dou y square into sin square theta. So I'm getting this value as dou square u by dou p square, which was this thing. So I got my one thing. Now by chain rule I will call it as A, keep it as it is for the timing, and then we will see what we can do in the. So for the timing, what we are going to do here, you observe it was x, it was dou u by dou y. So what it should had been, it should not be dou y, it should be dou y dou x, right? Now we are not doing any mistake. Sin theta, what we are getting is sin theta cos theta here, and here what we are getting is sin theta, right? Sin theta into this value, which is sin square theta, this value, and here it will be dou y by dou x. Here it was again, and here in this scenario we are getting the same thing. Dou square cos theta sin theta, right? Okay, so we are done with this thing. Now what we are going to do, we are going to do by chain rule again. Here you cannot say similarly, okay, because it is a second derivative problem, but similarly you can get this part, which was the first derivative part, you can derive it similarly by directly saying similarly. Similarly dou u by dou q will be nothing but dou u by dou x. Straightforward, we are going to differentiate it with respect to q, which will give you minus sin theta plus dou u by dou y. Here you are going to differentiate it with respect to q, you will get cos theta. Now you got the thing which you wanted, you will call it as some b. Now partial db by dp will follow the chain rule of as it is, because the partial differentiation, the partial derivative of b will follow the same chain as the first derivative follow. That is the property, okay, for that derivative, okay, for p that derivative. So here I know this, so partially differentiating b with respect to p, let me get the next page. It will be dou b by dou p, which will be by graph, I will say it is dou b by dou x into dou x by dou p, and dou b by dou y into dou y by dou sorry, we are differentiating it with respect to q, right? Not with respect to, okay, we did a mistake. I am correcting it here. Everything is right. Okay, this was the mistake. Here it will be q, and here it will be q. We have differentiated and got the proper things, right? Everything is proper. Now dv by dx and dx by dq value, dx by dq value I will substitute, which is similar to the previous one, minus sin theta, and here dv by dy, which will be cos theta. Okay, so what we are going to get is cos theta. I am going to get this side, dv by dy minus dv by dx sin theta. So cos theta dv by dy is nothing but I'm going to substitute this value here, dv by dy, which will be what? dv by dy, I'm going to substitute. The moment I substitute b value was what? Let me check the b value from where we were getting. Okay, which was dou u by dou y cos theta minus dou u by dou x sin theta. This thing minus sin theta into dou by dou x. B is what? Dou by dou u by dou y cos theta minus dou u by dou x sin theta. We are going to simplify this cos square theta into dou square u by dou y square. Here it will be minus dou square u by dou y dou x, dou y by dou x into sin theta into cos theta. Similarly here it will be sin theta into cos theta minus that also dou by dou x, dou square u by dou x dou y, and lastly it will be plus dou square u by dou x square sin sin outside it was dou b by dou y. Here it will be dou b by dou y, sorry, it will be dou b by sin theta cos theta dou x square. Here it will be, if I multiply this, it is y. We know this dou v by dou y is y. So if I simplify it, here y will go inside and it will become dou square by dou y square. One thing, sin theta into cos theta. Here it is y, it will become minus plus will be as it is sin square theta. Now if I add, call it b, add a and b. I'm sorry for this writing, okay, because the question is second order, okay, and these questions are a bit more lengthy. So if you observe clearly, if I add a and b, where is my a? Where is my, okay, this thing, dou square u by dou x square cos square theta, and here we have dou square u by dou x square sin square theta. So I'm knowing that dou square u by dou x square will be left only. So here sin theta cos theta dou square u by dou x and dou y, and here minus dou square u by dou x dou y sin theta cos theta. So this term will cancel out. Similarly here plus dou square u by dou y square sin square theta into cos theta. Here it is, wait, let me check, dou y square theta, it is sin square theta. It is multiplied throughout by sin theta. Here it is multiplied throughout by sin theta. We are getting two terms from here and two terms from here, which was supposed to happen. These terms get simplified, this term also. So here dou y square will simplify this one. My only problem is with this dou square u by dou y x, which is this, okay, which is also cancelling out. What is this term then? Two terms are gone. How we got? Okay, here also four terms are there. Here also four terms are there. Dou y dou x, dou y dou x. Twice this term is there. I think here also twice will be the terms. Like here it was dou u by dou x, here it is what, x. So this one will be dou y. dou y dou x. So this will be again twice, and since it is twice and this one is positively twice, they will cancel out, and I will finally be left with dou square u by dou y square. So which is the required thing if you observe. We wanted to prove that dou square u by dou x square plus dou square u by dou y square. First what we did, we simplified it, Gauss first order, then consider it as a, partially differentiated it again. Since the partial differentiation of that of the similar with respect to p will follow the same chain, so we partially differentiated it. We substituted the value, and then we substituted the a value, then we multiplied. From here we got dou square u by dou x dou y, and here you have to mention at each step when you are solving, you have to mention one property: dou square u by dou x dou y is equals to dou square u by dou y dou x. This is the property of partial differentiation. Then only you are allowed to cancel these two terms, these two with these two. So hence proved. So we are done with the chain rule, and in the next session we are going to start with implicit function, which is the next part of partial differentiation. Thank you.